Hi Scoop fans, Mercator makers and Arduino artisans. So today we're going to do a science experiment. I know I've talked about this before, but basically what I want to have is Mercator Origins to have audio directions. So audio can mean turn left, turn right, it can mean a buzzer, a low buzz, a high buzz, or it can mean vibrations. And the whole point of this is someone who can't see too well might be able to actually use this to have a dive with an instructor. So the thing is, how are we going to do this with the setup which we've got at the moment? Well, my idea is that at the moment we've got one GoPro case on this side of the wheel and we have nothing apart from our dolphin on that side. So the idea is that inside a second GoPro case we have a speaker, we have a battery, we have an MP3 player, and that MP3 player will have tones, it will have instructions, and basically a selection of things where we can find out what would be good working underwater. So I'm going to be putting that onto here one way or the other, and the idea is that this navigator is going to have to communicate with the second one to say go left, go right. But I don't want to have another hole drilled in the inside of that one, and I don't want another hole drilled inside of that one. It's just inconvenient to have another cable. So originally I was thinking about lasers. You'd use maybe LEDs, but underwater the actual diffraction of the water is going to interfere. So lasers would be probably more useful, but I would have to do a load more circuitry to do that. So I just thought, well, why don't we try something called ESPNow? And what ESPNow is, it's like Wi-Fi. It works on 2.4 gigahertz, just like normal Wi-Fi does, but it's designed for Internet of Things devices. And what that means is it is a lot more basic type of protocol. It doesn't take as much setting up of a connection. So it's designed so you could have something just communicate once a day, for example, back to the base station. And what that means is that I can send small messages and it doesn't take as much power. And I can start and stop it without it having to set up and establish a connection again. The question is, does it go underwater? Does it go through water? 2.4 gigahertz is the same frequency pretty much as what a microwave oven uses to heat water. So it can't go very far. The question is, can it go the short distance, which is maybe less than 10 centimetres, between the two of those? Because if it can, then we've got a communication medium, which means we don't need to make holes. And I don't need any extra components because it's the actual chip inside one of these that has got the Wi-Fi built in. It just runs in a different mode if I'm connecting to my home Wi-Fi. So what we're going to do first is I'm just going to show, if my assistant can come a bit closer. At the moment, they call them master and slave. So at the moment, it's just starting up. I've got a little pause on there. And we've got slave on the right here, and we've got master on the left. So at the moment it's trying to connect. They're just setting up their connections. They had a little bit of a pause, and so we just wait. Okay, so at the moment now, the master on my left side has managed to send one message over to the slave. It's now sent a second message, and all it's doing is it's sending one byte or one character, and you can see that it just sent a hash to the slave. And next time it will send, £. And it's just doing that every few seconds. So that is working between the two. And this in free space, in air, would work for probably 100 meters or more. The question is, what does it do underwater? So we've got 8 liters of fresh water here. We've got some lead in the bottom. That will become clear why we have that in a moment. I have one little Tupperware pot there with a half kilo weights to make sure it doesn't float. This is the slave, so we're going to put the lid on that. Let's put the lid on that. Okay, so you can see it's still periodically receiving a piece of information from the master. So let's put that into the water. And if I can just ask my camera assistant whether they can still see that text. And yeah, and as you see, it just updated. So I haven't put the master in the water yet, but the master is this far away. If you zoom out a bit, you'll be able to see how far away it is, and that's working. Okay, that's a good sign. So now we take the second Tupperware box, we put the master in there, and close it up, and we put this over here. And now, what we're going to do is see if the updates still get from the master on the left to the slave on the right. There we go. So master just sent, I can't see what it sent. On the left, on the right side, I can see it sent a slash character, and now it's sent another one. So what we're going to do now is measure how far has it actually gone. We can see that is actually further than you need than the gap, which is basically the thickness of this spool. So we're already on good ground. But let's do a proper experiment, find out how far away these are. Now, I'm going to measure from the centre of each one because that's roughly where the chip is. So if we put that underwater, we've got basically 15 centimetres between the centre of each one. Now I'm going to move this away to the top corner of my pot of water, and now we can see if it still works. Right, now we'll say found it. And that's still working, which is interesting because earlier on it didn't actually go quite that far. So I think we are at the edge of what this thing is able to do in fresh water. So let's just try that. So if we have a look on the slave side, because that's what will tick if we've still got data transfer. Well, it's still working. Okay. Well, I'm not going to go further than that, obviously, because that's the size of my bucket. But what I am going to do now is, we know now that this is fresh water, so if I'm in Raspberry Lake, which is fresh water, I'm going to be able to have two of these communicating to each other with water in between. Perfect. So the question is, what happens if we were in seawater? So seawater has got between 3.5 and 4% salt. So 3.5% is what you'd have in the English Channel. 4% roughly is what you have in the Red Sea, which is pretty much the most saline sea you've got, except for the Dead Sea. And we're going to ignore that, because that's got 320 grams of salt per kilo of water. So what I'm going to do is, we've got some samples of rock salt here, which is basically what I use on my drive when it's icy. We've got 10 grams, sorry, not 10 grams, we've got 80 grams in each one of these pots. We've got 3 of those, and I've got 40 grams in each one of these glasses. So 8 litres, that means that basically if I put 80 grams of salt in there, then that means that I'm basically having 1% saline solution. So we'll dump that in. Now I need to get a little stirrer. And this is where we find out how easy it is to actually mix this salt in. Because it's not fine-grained salt, it's not the most convenient. So let's have a look. So basically, that's pretty much all of it dissolved. And as we talk more, it will dissolve a bit further. So the question now is it still ticking? Now, it's saying trying again. Trying again. So, is this because of the salt, or is it just because of something else? So let's just take these out a moment. I'm also going to make sure there's not water in these, because these are not officially supposed to go in water like this. Looks like, have we actually got water inside that one? No. That's a good job. Okay. So now it's able to send the signal again. So it's found it. It's sending the data again. So let's put this back in. Now remember, I did say earlier that when I first tested this earlier, that it didn't work the entire distance. So let's get them a bit closer. And let's see if it's ticking still. So remember, it's going to tick on the right side if it's going to work. Right, okay. So it's managed to send that data. It sent the letter A on the one on the right-hand side. We'll try let it go one more time. Okay, that's good. So let's move it over. We're already at the distance which we'd be happy with for the reel or spool. Is it still working? It's still working, right. Well, let's just, at this point in time, I'm just happy. I'm not going to be trying to get some maximum going on here. Right, so what I'm going to do now is I'm going to put in another 80 grams of salt. So now we're at 2% salinity once this stuff dissolves. Now the reason why I've got this, both of these little Tupperware boxes on top of lead is because I don't want the signals from the Wi-Fi basically going through the bottom of the bucket, which is a very thin plastic, and then basically communicating through the free space that's underneath. So by putting lead underneath, I'm kind of guaranteeing pretty much that it's not going through a shortest path which doesn't involve water. So that's why we've got the yellow blocks. About 3 kilos of lead, and although it's not absolutely solid, it's got a few holes in it, I'm not too fussed about that. Okay, so as far as things are going, that's pretty much dissolved. Let that settle down. We'll see what it's doing. Right, trying again. Okay, so let it try a few more times. Right, fail. Okay, so let's bring them closer together. See what happens there. I think that just worked, didn't it? So let's wait for one more. Yeah, that works. Okay, so let's move it apart. $36. That's okay. Right, so we're good for that. So that's 2%. Now I'm going to get the next one. That's the one. So that's now 3% once that's dissolved. And we're approaching now what the English Channel is, and probably what most of the seas of the world are, when you're in shallow water and not in a confined sea like the Black Sea, for example, or somewhere which is kind of cut off from the main ocean. So again, I'm just trying to dissolve this quickly. Right, that's pretty much there. Okay, so we're now at 3%. Now remember, when I've been doing this then, I just had my arms in the way. So look, that just worked. So it's okay. It's just sent the last message, and you can see that on the right-hand side, it says data Q, and the next one will be data R, and there we go. So that's worked. So cool, we're at 3%. And now we're going to put only 40 grams in, and this is going to make it 3.5% salinity. So this represents the English Channel. So remember, I'm in the UK, so the most likely place for seaborne diving, if you're not getting a plane, is in the English Channel or in the North Sea. They're joined together, so I'm not fussed about any differences. And to be honest, the whole globe is pretty much between 3.3 and 3.8 salinity. So really what we're finding out is, does it work in seawater as well as it works in fresh water? And there's another reason for doing this distance thing, because although it is more than the width of the spool, I am interested to know, could we actually communicate from the diver's arm, for example a heart rate monitor, under a dry suit, to the console, which would be a little bit more of a distance. And at the moment, it looks like we might have actually be in luck. So let's try that. So now we've got 3.5%, the English Channel, getting a bit murkier, which is very much appropriate for the English Channel. Trying again. We'll let it go one more. There we go. So it took a bit of time to re-establish after I made it all a bit mixed up. We'll wait for one more. VWX. There we go. Great. Okay, so it's going to work in the English channel. Now we're dealing with the Red Sea. So now we're about 4%. Red Sea is actually 3.8, but let's not split hairs. Let's mix that in. I'm very pleased how this ESPNow Wi-Fi works. Basically, if you think about how long does it take for your phone to connect to a Wi-Fi hotspot, it's not always instant, is it? Well, the whole point of this ESPNow is that it's pretty much instant. It's not as flexible as your normal home Wi-Fi, but it's perfect for these little microcontrollers to talk to each other with a small amount of data, and that's all we need. We just need a small amount of data so that the navigation console can tell the audio console play the file for left. It doesn't have to communicate the data. So there we go, 4%. It's trying again now that I've had my hands in there. It needs to settle down. Let me go one more time, get it a bit closer, because remember this is actually further distance than it would be in reality. Okay, let's bring it a bit closer. See if that helps. Yeah, there we go. Okay, so we're going to move that apart a bit now. We're just going to find out how far we can get these two apart. Still working. Right, so that looks like it's at its limit. So let's leave it tick twice more. It worked. Okay, let's leave it to tick once more. Fail. Okay, so as you can see, it's actually getting an acknowledgement back from the slave to say whether it's got the data or not. And in this case, it's not. So I think we're on the edge of what it's doing there. So I'm just moving it a tad closer. There we go. Okay, so I'm going to measure that. Centre to centre. Well, we're about 15 still. So actually, let's just check that. Yeah, about 15. So there's absolutely no difference between fresh water and salt water, which is great. And I think one thing to remember is because we've got these two microcontrollers facing upwards, which is chips this way, horizontal, if we go and put them back to back, which is effectively what they're going to be like, then it could well be, obviously not the lead either side, so if we go that way, then it could well be a bit more. But 15 centimetres, let's measure what real is, or spool, I keep calling it the wrong thing. The spool is, so from one side of the spool to the other is only 6 centimetres. And so if you add on the fact we've got two cases, even worst case scenario, 7 centimetres, 7.5. So we've got a factor of 2 allowance there. So what I'm going to do is hopefully this weekend, it's Friday, I'm going to get the audio module coded up. I've got the hardware all wired up. And then we're going to find out whether we can actually get these two to communicate in a bucket, which is a bit bigger than this, actually like that, without any cable. There you go. Isn't that good news? So that means that potentially next week we're going to do an audio test underwater with both modules, which I never thought we'd be able to do with the radio. So there we go. Enjoy, and we'll talk again next week.